Hey everyone, it's Dr. Chuck back with another refrigerant checkup. Today I want to do a continuation on one I did a couple of years ago, talking about the refrigerant naming and numbering system that we all use. So if you haven't looked at the old one in the past, or it's been a while and you've kind of forgotten how we name and number things like R134A or R410A or R407C, you might want to go back and check that out and then rejoin here. We'll put the links down below. But in any event, let's get started talking about naming and numbering HFO refrigerants. So we're going to start off with a couple of examples. Probably the most widely known HFO, R1234YF, 1234YF, very widely used in automotive air conditioning, also a component in a lot of both the non-flammable and mildly flammable refrigerants. So if we start with the refrigerant number, R1234YF, let's see if we can get the chemical structure based on that. Going back to the old original HFC numbering system, we know that the digits give us the chemical formula. So reading from right to left, we have a 4, that's the number of fluorines in the molecule. A 3 is one more than the number of hydrogens, so we have H2. The third digit from the right, the number of carbons, or one less than the number of carbons, so that's a 2. That means we have 3 carbons, and finally one olefinic bond, or one carbon-carbon double bond. So that gives us our formula, C3H2F4. And so let's draw out the structure here. So we start with the carbon backbone. It's 3 carbons and has an olefin structure. There's only one way to put that down. So C double bond C with another C. Now, as far as adding the hydrogens and fluorines to this molecule, we follow the standard, actually standard 34. And basically, we start looking at the central carbon atom there and what the constituent on that is. So there's a little table that gives us that. So we see that for Y, that would be a fluorine. So we put that fluorine on the central carbon atom. And then to complete the molecule, we look out at that double bonded C on the end, that methylene carbon there. And again, we look at our digits and we see from the F on that, that would be a CH2 group. So then everything else falls into place. We just have the rest of the 3 fluorines that will go on the other end of the molecule to make it CF3. So there you have the full structure of R1234YF. Which is in chemistry talk would be 2,3,3,3 tetrafluoro-1-propene, or otherwise known as HFO 1234YF. So let's extend that to another molecule you may be familiar with, in this case 1234ZE. So the 1234, we know it's going to be exactly the same chemical makeup, it's just going to be a different arrangement of the atoms. So again, we can start with that basic 3-carbon olefinic structure. And then we look at that central carbon atom. In this case, the Z is going to be equivalent to a hydrogen on that. So we put a hydrogen there, and then we look over to the methylene carbon, the double bonded carbon on the left side of the molecule, and we see from the E, that's going to determine that we have a hydrogen and a fluorine on that. So we fill in those. Again, we're left with the 3 fluorines from the molecule to put on that third carbon, and there we have the complete ZE molecule. Now ZE, it turns out, goes a bit further in ways it can be arranged. There's 2 possible arrangements or isomers. The cis and trans, if you took organic chemistry, or Z and E in some of the other nomenclature. And that refers to how symmetrical or how arranged the groups are around that double bond. Are they on the same side or on the opposite side? So you can see for the trans or the E isomer, the 2 hydrogens are across from each other, and on the Z isomer or the cis isomer, they are on the same side. So again, these are physical property differences. These molecules will have different physical properties, including things like boiling point. So it's important when you get to these type of systems and molecules where these isomers are present or are possible, that you specify exactly what molecule you're talking about, because there are variations out there. And finally, let's extend the HFO naming system to something larger than 3 carbons. Let's go out to a molecule you may have heard of with 4 carbons, 1336. The one you're familiar with is 1336 MZZ, I would predict. And again, based on our standard HFC, HFO naming system, we would know that C4H2F6 is the molecular formula. So you start out at one end of the molecule and start adding it and building it together, adding letters as you go until the structure is definitively defined. So if we look at MZZ, the M will tell us that we start with a CF3, and then Z being a CH, so that's going to be on the double bonded carbon. And then we have another Z, so it's another CH, and again, the end is already defined by what we have left over, so that would be a CF3. So 1336 MZZ, component of a pure fluid being looked at for some heat pump applications, also in low pressure chillers. But again, CF3, CH double bond CH, CF3 is the molecular structure for 1336 MZZ. This goes on and on. I can do more examples if you'd like. If you have a specific question or want to go the other direction, any questions how this works, just let me know. It's pretty straightforward. You can get a couple of cheat sheets there and you can go either way if you really want to understand what the chemicals are, what their structures are, based on some of the shorthand nomenclature that a lot of us use without thinking too much about it. And sometimes we get somebody new to the field or somebody says, what exactly is that molecule? This way you can give them the exact chemical structure if that's of interest. Again, I hope this is helpful. The original naming and numbering video you can find online. We'll put the link down below. But if there's anything else around refrigerants, chemistry going on, applications, safety handling, training that you need, please feel free to reach out to us here at Chemours. We have a lot of experts and we can get you the information you need. Please stay safe out there. Have a great day. Thanks for your business. So long.